Okay, so we're going to start by figuring out, in order to find where f is increasing and decreasing, first we need to find where it could change, the derivative could change sign, which means we first need to find our critical numbers. And of course, to do that, again, we're going to need to find our derivative. So to differentiate this, we have f prime of x is equal to 3x squared minus 3x. We want to know where this is equal to 0 or undefined. Since this is a quadratic, we know it's going to be defined everywhere, so there's not going to be any points where the derivative doesn't exist. To figure out where this is equal to 0, we're going to need to factor. We can factor out a greatest common factor of 3x. That's going to leave us with x minus 1. So then we could have that 3x is equal to 0, or x minus 1 is equal to 0, which means that our critical numbers are at x equals 0 or at x equals positive 1. So now we can use those critical numbers and we can check the sign of the first derivative on either side of those critical numbers, and that's going to tell us, based on the sign of the first derivative, where our function is increasing and where our function is decreasing. So if I plug in a value that is less than 0, if I plug in a negative number, then I'm going to have a negative number, 3 times a negative number here. And then if I plug in something that's less than 0, if I plug in a number that's less than 0, then this is also going to be negative. So I'd have a negative number times a negative number is going to give me a positive. So for all of the values where x is less than 0, our function has a derivative that's positive. If I plug in a value that is in between 0 and 1, then that's going to be a positive number. So 3 times a positive number is positive. But if the number is between 0 and 1, if I subtract 1 and it's less than 1, then I'm going to get a negative. So I'd have a positive number times a negative number would give me a negative derivative. And then finally, if I plug in a number that is greater than 1, I would have a positive number times 3 is positive. If I plug in something that's bigger than 1 and subtract 1, it's also going to be positive, and a positive number times a positive number will give me a positive, which means that in this region, my function must be increasing because its derivative is positive. In this region, my function must be decreasing because its derivative is negative. And then finally, in my last region, again, my function must be increasing because its derivative is positive. So now that we've established those intervals, all we have to do is write that information out. We know that f is increasing for all of the values that are less than 0 and for all of the values that are greater than 1. And the reason we know that is because the first derivative is positive. You could also write the first derivative is greater than 0. We know that f is decreasing for all of the x values between 0 and 1. And we know that because its derivative, f prime, is negative in that region. Again, you could also say less than 0. Either one is acceptable. In this case, they didn't ask us for whether or not the points were relative extrema, but we do know that we have a relative max at 0. Because we started with a cubic function, we know that our function is going to be defined for every value of x. So we do have a relative extrema, a relative maximum, specifically at 0, because the derivative changed from positive to negative. We also know that we have a relative minimum at 1 because we know that the function is going to be defined at 1 and the first derivative changed from negative to positive. So we'd have a relative maximum at 0 and a relative minimum at x equals 1.